Hey guys, so I'm back with more Webassign help. So this is for the current Webassign chapter 5 and 6, which is going to be on Newton's laws and the application of his laws. I'm going to start on number 19, which is the one about two angles with two tensions in it. Now, this entire question hinges on the fact that you know the net force acting on the sine is going to be 0, which means everything cancels out. You already know what that means in the y direction, that T1 sine 43 plus T2 sine 55 equals the weight of the sine, which in my case is 419 newtons. But the two forces also equal out on the x direction. In this case, tension 1 cosine 43 equals tension 2 cosine of 55. There's a free body diagram here, and you can tell from that. Now what you basically have to do now is use what's effectively a system of equations to find one or the other. So you will multiply, what I did was I multiplied this side by cosine of 43 over sine 43. And then, you basically make one of these two terms cancel. And you should get roughly this, because for here, you can also turn it into this. My bad. By manipulating the function, you get this. And then by subtracting this from this, you get that 1.452 T tension. The second tension equals 525.46 newtons. And from these two things, you can derive the tension of number 2. And afterwards, you can just plug that in to any of the other functions. The value you got for the tension of wire 2 to find the tension of wire number 1. Now you could do this in any order, really. You could have multiplied this by t sine cosine 55 and added, and you'll get the same answer. Alright, moving on. Alright, I'm going to move on to number 22. I don't think this is a particularly hard question, but it seems that the fact that we have to use basically variables, which we seem to know, it seems kind of counterintuitive. But for part A, you get that the total force equals mg equals mass of this object times gravity minus tension, which also equals the mass of this object times its acceleration. Now, you know that the tension force equals this mass times acceleration. They just happen to be the same thing. So you can basically plug in ma for t here, and you get mg minus ma equals ma. Or basically the weight minus the tension will equal the net force. It's a really nice coincidence. And then you can just manipulate things in this equation and get that g equals 2a and a equals g over 2. So the acceleration of block A as it descends will be g over 2 meters per second squared. For block B, for part B, block B strikes the floor and does not bounce. Determine the time determine time sub 1 at which block B strikes the floor. What you're basically doing here is plugging this into a kinematic, now that you know acceleration, even though you really don't know it. But you get, I'm subbing in h for delta x. So h equals 0 times t, because there's no initial velocity, plus 1/2 of g over 2, which is g over 4 times t squared. And then we have to divide both sides by g over 4. Which gets you 4h over g equals t squared. Take the square root of that, the 2 comes out of it. It'll be just square root h over g. Be 2 square root h over g for the time. Now, I don't know why that word is misspelled. It's really stupid if I don't know. Anyway, for part D, you have to determine the distance between the two landing points. Now, the first block block B does not have any horizontal distance. When it hits the ground, it's directly below where it's dropped. And you know that's going once B hits the ground, which is before A leaves the table, once it hits the ground, A stops accelerating. So we first have to find the final velocity of A, which is when it falls off the table. Now we have to use two different things for that. Now we have to use our first kinematic, where it's v equals v naught plus at. And since we know both the time it takes for B to hit the ground and the acceleration of B and A, we can tell that this is the final velocity that block A is going to be going after block B hits the ground. So when block A comes off the table and goes into free fall, it'll be going at this speed. Now, since this is constant velocity, we can just use that delta x equals velocity times time. And now we have the velocity right here, so what we do have to find is the time. Here I'm just plugging this into another kinematic, which is the amount of time that it takes A to drop once it goes off the edge of the table right here. It will fall 2h. So 2h equals 0t, because this is in the y direction only right now, plus 0.5g t squared. This is kind of going back to the previous chapter. You get that 0.5g t squared equals 2h. By basically moving things around. You find that then by dividing both sides by 0.5, you get that t squared equals 4h over g. And then you have to take the square root, and like the previous question, you'll get t equals 2 square root of h over g for the time. Now you take the velocity you got earlier, this, and the time you just got, and you can put it together to find the delta x. And if you plug it all together and multiply it out correctly, this g and this g should cancel out, and this should end up being, it should get rid of the radicals, and then the 2 and the h will be the only thing left, and your answer will be 2h.